close the door? Okay. So good morning to everyone. So good morning. Okay. Whether all of you are here? All of you are there? Or still students have to come? Okay. So since it will be my first class, right? So you people don't know me. Who is this fellow? Okay. So myself, Dr. Raghavendra Hegde Katte. Okay. So I will be handling chemistry. As you know, in the timetable it is mentioned as chemistry. So I will be handling the chemistry. Okay. So any doubts? Whenever I will be teaching, in between if you have any doubts, you are always welcome. You can ask or you can raise the questions. Fine. So any one of you are from Kannada medium? You can just mention yes. Any one of you. If you are from Kannada medium, you can just type it as yes. Okay. So now we will start with the class, and once again, if you have any doubts, you should ask at that moment itself. Don't postpone it. Sir, pata ಮಾಡ್ತಾ ಇದ್ದಾರೆ. So how to ask the question? Sir will get disturbed. No, I will not get disturbed. So I want you to have clear picture. So don't go with any doubts in your mind. Fine? So shall I start? So we are going to start with the basic concepts of chemistry. Okay? So this is the topic which we are going to discuss. So which is that one? Basic concepts of chemistry. Now when I am talking about this particular chapter with respect to the board exam, you are going to have marks somewhere around 5 to 6 marks question. Normally it will be for 5 marks. Okay, so that's where one problem might be there. Which one? I will let you know. And whenever I will be talking about the concept, I will mention whether it is important or not. Anyway, with respect to your competitive exams, once again I will repeat. So with respect to your competitive exam, nothing like this is important, this is not important. Each and every word of your NCERT textbook you have to follow, because all of us we know we have to go with the NCERT book, right? So therefore please remember you have to read each and every word of this particular textbook. So it has been narrated beautifully, so you have to enjoy the subject. So therefore if you have any doubts, let me know. That is one thing. Another very important thing here is, if you want to enjoy the subject like chemistry, then we have some of the chapters, because your syllabus itself is designed in such a way that whichever is crucial to understand this subject, they have put it before. Okay? Say for example this chapter, it is the first chapter of your chemistry. Okay? Now when I am talking about this particular chapter, along with this we have the atomic structure, then along with the atomic structure we have the classification of elements, then we have the chemical bonding. Then we have the chemical bonding. Then similar type of title, that is basic concepts of organic chemistry. Basic concepts of organic chemistry. I am using some short form. Organic chemistry. Then we have the hydrocarbons. Then we have the hydrocarbons. Now, according to me, if you have learned each and everything from these chapters 1, 2, 3, 4, 5, 6, then it will be easy for you to understand the other chapters. It will be easy for you to understand the other chapters, not only in first PU, even in second PU. Okay, board is not clear. 1 minute. Okay. Hello students.
No, it is okay. Close that. Close window, please. Close window.
Now they are telling it's clear.
Close the window. Completely close. And also the gap should not be there. Yeah. There also gap. That gap. Overlap. Yeah.
Okay. Now it's clear? Yeah, I think it's clear now. We can just mention Shashank. Now whether board is clear? Okay, fine. Now, what I mean to tell you is when it comes to first year, we have some of the chapters where we have basic concepts of chemistry, atomic structure, classification of elements, periodic classification of elements, chemical bonding, basic concepts of organic chemistry, and hydrocarbons. So if you learn this chapter, that's what I was telling. Now it will be easy for you to understand the other chapters of chemistry. That doesn't mean that only this chapter you will learn and you will get the marks. No, I don't mean to tell. I'm not mean to tell that one. So I wanted to tell here is, if you learn these chapters, then you can understand other chapters easily. That's what I mean to tell. Fine. Now, when it comes to first chapter, that is basic concepts of chemistry, not organic chemistry, chemistry. So with respect to board exam, you can expect 5 marks. Okay. Now, when it comes to competitive exams, that's where you can expect 1 to 2 questions. I will mention it as 2 questions. Fine. All of you have understood? That shows the importance of this particular chapter. And many things in this chapter is repetition. If you are from CBSE or state, so it will be repeated. Some of the concept which you have already learned in your 10th standard, same thing is that here also, but in bit detail. So therefore, try to understand the chapter properly. Whenever I will be telling any concept, try to focus on those concepts and try to don't miss the class. Okay? Since it is an online class, many students, they will miss the class, maybe due to network problem, that and all. We can't do anything, but otherwise don't miss the classes. Okay? Not only this one, all the classes, any subject. Fine? So in that case, we will start with the basic concepts of chemistry, where the first part, that is SI unit. You have the SI units and all, it is there, which we people are going to discuss in your physics in detail, and where it will be important for your exam point of view also. But when it comes to chemistry, with respect to SI units, it will not have much importance. Means it is required for your knowledge, but for your board exam point of view, on this particular concept, you will not be expecting any questions based on the SI units. Okay. So before going to SI units, already I think madam might have told in basic chemistry, whenever madam is teaching, she might have told. So now what I mean to tell you is, what is chemistry? Chemistry is nothing but study about the matters, right? Study about the matters. So that's where I told you people have studied these things in your SSLC or 10th standard. So that's where we have the matters. Now when I am talking about the matters, when I am telling apple, you will imagine the shape of the apple, right? When I will tell water, you will imagine the water. So that's where matter, these can be imaginable because they have their own dimension, right? So they have their own mass. So that's where we have the matters, which have their own mass. Okay, so which have their own dimension. That's where we have the matters. Now, in chemistry, it is nothing but study about these matters. In chemistry, it is nothing but study about these matters. Okay. Now, when I am talking about the nature, we have different varieties. For example, we are living in this earth. We are surrounded by the mixture of gases. We know that it's not only oxygen which is present in the atmosphere, we have much more higher concentration of nitrogen. That means this atmosphere is not a pure component, it is a mixture, right? So that's where we have the mixture, right? So best example is, that's what I told, atmosphere, gaseous mixture where nitrogen and oxygens are present in different ratios, where nitrogen will be dominating. Fine. So same way, if I take a water, Kaveri water, whatever it is, where H2O, water is nothing but H2O, right? So where water content might be more, but it is not pure. It is mixed with some of the minerals, some of the salt, right? So that's where we have the mixture which will be present in the nature. But at the same time, we have the pure component also. At the same time, we have the pure component also. What I mean to tell here is, I am talking about different types of matters which are present in the nature. So matter can be pure or in a mixed form. See, for example, I will take a glass. Now you should start imagining, and in which I will put some amount of water. I will put some amount of water, and to this I am going to add some of the soil. Okay, I will add some of the soil particles and I will mix it nicely. Always I will be challenging my students. Okay, since it is online class, anyway, I will give a challenge. Without using anything, you can take any number of days. Can you make this soil to get mixed properly with the water? So if anyone does that one, I can give 1 crore. 1 crore. Okay? So whether it's possible? No, it's not possible. That's why I'm confident. When I'm mixing soil with water, when I'm mixing it properly, in the beginning it looks like there is a change in the color of the water. It has become brownish color. Yes, it's not possible. Yes, Rishabh. So it looks like it will become brownish, or depending on the nature of the soil, it will have the colors. But when you keep it for some time, after 1 hour, if you come back and if you see the glass, all the soil particles will be settled at the bottom, and upper part will be a pure water content, right? So that's where soil and water mixture can be the example for heterogeneous mixture. It can be the example for heterogeneous mixture. So once again, for Kannada medium, if at all, if you are there, I have written heterogeneous means Vaividhyamaya. Okay, heterogeneous means Vaividhyamaya. That's where we have the heterogeneous mixture. Same way, if I take a glass of water, if I take glass of water and if I add salt to that, if I add salt to that, 1 minute. Okay. So if I add salt to that, whether we can have the salt which will be settled at the bottom, any one of you? I have a glass of water, to that I have added a pinch of salt and I have mixed it properly. What will happen? It glass of that water, it will have its original color itself because salt does not have the color. When mix it properly, you cannot see where the salts are present, right? So it will be properly mixed. Yes, Kritik, it will get dissolved. That is the word. It will get dissolved. Salt is soluble in water. Soil particles are insoluble in water. That is the word, right? So that's where I have the salt. When I add it to the water, now if you keep it for 1 day or 2 days, right? Yes, Parva, if you keep it for 1 or 2 days, whatever time, there is no question of settling of the salt at the bottom of the container, right? So that's where I have the homogeneous mixture. That's where I have the homogeneous mixture. Now, Ekarupa. Homogeneous means Ekarupa. Okay, that's where we have the heterogeneous mixture and homogeneous mixture. In short, I can tell that mixtures are those where two different components are mixed with each other. They are nothing but mixtures. So what are mixtures? These are the component where two different types of matters are mixed with each other. Then it will lead to the formation of the mixtures. Fine? All of you have understood? Shall we go to the next one? That is pure matters. Matters with respect to their pure form. Now in that way, I can tell that I have two categories. When it comes to matters in pure form, I have two categories. One is elements. One is elements. Elements means anu. Okay? So that's where we have the elements. Anugalu. Kannadadalli helbeku andre. Okay? So pure form, elements. Now at the same time we have the compounds. At the same time we have the compounds. So that's where I have the pure form of the matters. Fine? Now, what do you mean by matters? It can be called as dravya, right? Dravya Rashi. If I am wrong, okay? So matters means dravya Rashi. That's where we have the pure elements. Pure form is elements and compounds. Fine? Now, if I take oxygen atom, if someone tells you, write the formula for oxygen atom. Now, what you are going to tell? What you are going to write? If someone asks you to type the formula for oxygen atom, if someone asks you, who is teaching chemistry class today? You will tell Raghavendra sir. Right? Same if someone tells you, write the oxygen atom. Represent the oxygen atom on the board. How you are going to represent? By a symbol. So which is that symbol? You will just mention it as O. Oxygen atom. It is an element where only oxygen is there, pure form. So it is an element. If someone asks you to represent the oxygen molecule on the board, oxygen molecule, whatever I have mentioned here, it is oxygen atom. Now I am telling oxygen molecule. If someone asks you to write the oxygen molecule on the board, how you are going to represent? Right? How you are going to represent that one? You are going to represent that one by writing O2. We are going to represent that one by writing O2. Right? So same as we are going to write our names, which is going to represent Raghavendra sir on the board by writing the name, or any one of you by writing your name on the board. It means that you are talking about that particular person. Same way, each element, it will have their own representation, symbolic representation, right? So that's where someone has written O2. Yes, Rishabh, absolutely correct. So that's where I have oxygen atom, where only O, one O. If I am talking about oxygen molecule, where I have to write O2, where I have to write O2. So that is the difference between oxygen atom and oxygen molecule. Both are the example for pure components of the matters or pure form of the matters. Sir, in that case, when I am talking about pure form of matters, only one type of element should be there. That means only one type of atom should be there. Not compulsory. It's not compulsory. Do you get my question? Question here is, there should be a question we should be raising into your mind. That question should have been whether in that case, pure form of matters, if I am talking about, whether only same type of element should be involved. Because whatever I have taken the example, in both the cases, oxygen atoms are involved. Whether only oxygen atoms, since same type of atoms are there, whether that's why they are pure form? No. It's not the answer. It's not correct. Fine. If I take glucose, a very common molecule, you people have studied in biology part of your science textbook and even in chemistry also, that is glucose. What is the formula for glucose? Any one of you? What is the formula for glucose, if you remember? If I am right, it was there in your textbook, in your 10th standard book. What is the formula for glucose? Okay, so that is nothing but C6H12O6. C6H12O6. Same if I take water. Sir, I want to represent the water on the board. So that doesn't mean that I have to throw some of the water on the board. See here, I have the water. No, that is not the one. I have to represent the water by the formula. Right? So what is that formula? Water is having formula H2O. Very common molecule, H2O. Right? So what I mean to tell here is, when I am talking about glucose, I can see 6 atoms of carbon, 12 atoms of hydrogen, 6 atoms of oxygen. They are combining together to form the glucose. Oh, all of you are correct. Right? So they will combine together form the glucose. If I take water, I can see 2 hydrogen atoms and 1 oxygen atom. They are combining together to form the water. Right? So whether I am representing glucose in India, in Mysore, or whether I am representing the glucose in Mumbai, whether it will be same or different, it has to be same. Formula cannot be changed depending on the place. In USA also, if I am writing glucose, I mention it as C6H12O6 only. So what I mean to tell here is, in this particular proportion only, these elements are present in these molecules. In glucose, what is that proportion? Proportion means pramana. What is that proportion? That is C6H12O6. 6 carbon, 12 hydrogen, 6 oxygen. Same way water. 2 hydrogen, 1 oxygen. And always, if you observe it carefully, all these atoms will be represented by the capital letters, right? Capital letters. And whatever numbers are there, it will be represented as a subscript. If I write glucose as C6H12O6, this is wrong. This is wrong. I cannot take numbers in the same way as that of the alphabets, right? So I should go with the subscript with respect to the number. That's what we have taken it as a one of the format to represent the molecular formula. So that's where I have the molecular formula for oxygen molecule, molecular formula for glucose molecule, molecular formula for water molecule. Now I have a question. Okay? Now I have a question. So whatever we have represented over here on the right side, they are all example for pure form of the matters. Whatever I have represented on the left hand side, they are all the example for the mixtures. They are all the examples for the mixtures. Then what is that difference between these two? In a mixture and a pure form of the matters, what is that difference? Any one of you? Whatever I have represented on the left hand side, they are the example for mixtures. Whatever I have represented on the right hand side, they are the example for pure form of the matter. What is that difference? Observe and let me know. One should not by heart anything. I don't want my student to by heart any of the concept. That is not the good way to learn. If you understand the concept, easily you can write it down. So by observing the board with the example I have written, can you tell me what is that difference between mixture and a pure form? Sir, ನೀವು ಕೇಳೋ ಕ್ವಶನ್ ಹೇಗಿದೆ ಅಂದರೆ if you are live in front of you, then only we can give the answer. Whether we have to type it now, right? Okay, fine. Now if I take here, I have NaCl. Salt is nothing but NaCl, and which is mixed with the water. Which is mixed with the water. That means two different molecules. Two different molecules, they are combined. Two different molecules, they are combined in one container. That's why they are called as mixtures. That's why they are called as mixtures. Rohan, I'll come to that. Yes, you are right. I'll come to that. So they are called as mixtures. Two different components, they are present together. Right? But here, that is not the case. Here, that is not the case. We have the oxygen molecule as it is. We have the glucose molecule as it is. We have the water as it is. Right? So that's where I have the pure and mixture. If I am going to add glucose to the water, then it will be a mixture. Then it will become a mixture. So now I am not adding glucose to the water. I have represented it separately. So therefore they are the pure component. All of you have understood? Any doubts? Any doubts in this? Okay, fine. So in that case, now you have a view that what is that difference between mixture and a pure component, right? So mixture means where two or more than two molecules are combined together. Here it's not combined, they are separate, right? Now someone has told about the separation, right? If I take NaCl and water, a very beautiful example. If any one of you have visited Gokarna, right? So it's my native place only. So if you visit that particular place, on the way we have one particular place which is called as Sanekata. That is the name of that place. Don't get confused. So then they have a preparation of salt. Table salt. They are preparing the table salt which will be brownish in color and which will be good for health. Whatever salt we are using here which is white color powder, actually it's not good for health, and that particular salt is good because it is having some of the important component which is required for our system. Okay, so how they are going to prepare that salt? It is just by the evaporation. Later some process will be there, but first step I am telling, where they will collect some of this salt sea water and they will put it in a place in between the sea water. There will be shallow water will be there. They have created that one. On that they will put that water, and due to the sunlight, due to the evaporation, after some days there will be deposition of crystals. So how it's possible? Because all of us we know that sea water is enriched with NaCl. Therefore we cannot drink that water. If you are in a ship but you don't have the sweet water with you, then in whatever thirst you have, you cannot satisfy that one by using sea water, because it will going to enhance the thirst feeling, right? Because of the high concentration of NaCl. So now water and NaCl, they can be separated easily by the evaporation process. All these things you have studied in your high school class. By evaporation process you can separate that one, right? So I have petroleum products which are combined together. Now I am getting in a petrol bunk, diesel separately, petrol separately. But whether in the nature it is present like that? No, they are all mixtures. But they will be separated by fractional distillation process, which you people have studied once again in your high school. Same way, if I take atmosphere, I can take out the oxygen from this atmospheric gas. I can separate the oxygen from the nitrogen. Right? So that's what. When I am talking about the mixture, here whatever two molecules are there, they can be easily separable by the physical methods. They can be easily separable by the physical methods without using the chemical reactions. They can be separated from each other. That is where we have the mixtures. But when I am talking about pure components, where if I want to separate carbon, hydrogen and oxygen from each other, then it's not possible simply by boiling, right? It's not possible by distillation. I have to go with some chemical method where I have to break the bond. I have to break the bond. That's where I have the pure component of the matter, right? So all of you have understood? Fine. So now in that case, if I see on the right hand side, I have three types of molecule. One is oxygen molecule, one is glucose molecule, and one is water molecule. Why they are called as molecule? Because more than one atoms are combined together. More than one atoms are combined together. Therefore, I will call them as a molecule. But this one, oxygen atom, is not a molecule because single atom is there. It's not a molecule. Now, if I compare between oxygen molecule and glucose molecule, what is that difference? Can you see any difference? Of course, yes. What is that difference? Here, two oxygen, they are combined together, but here, carbon, hydrogen, oxygen, they are combined together. Got my point? So in case of the glucose, two different atoms or three different atoms, they are combined together. Which are those three different atoms? One is carbon, another one is hydrogen, and another one is oxygen. In case of the glucose. But when it comes to oxygen molecule, it is oxygen is the one which is combined together. Right? So therefore, now listen to me carefully. Oxygen, glucose, both can be called as a molecule, no doubt. Both can be called as a molecule. But I will be very clear here that oxygen cannot be called as a compound. Oxygen molecule cannot be called as a compound. But glucose, yes, it can be called as a compound. Glucose can be called as a compound. Even water, whether we can call it as a compound? Yes, because two different atoms they are combined together. That is hydrogen and oxygen. Right? So that's where we have the difference between compound and a molecule. By seeing this, I can tell that all the compounds are molecules, but all the molecules may not be compounds. I can give a statement. What is that? All the compounds, are molecules, no doubt. But all the molecules may not be compound. But all the molecules may not be compounds. All of you will agree? Any doubts? May not be compounds. That is the difference between compound and a molecule. Molecule is a broad term, but compound is a bit specific, right? So what is that the specificity of the compound? Compounds are those molecules where more than one type of atoms they are combined together. Okay? So that's where we have the compounds. Any doubts? This is where we have the matters. Okay? Any doubts? If you have any doubts, you can type it fast. Okay? Now if you observe in this particular concept, what and all we have discussed? So we have discussed about some of the words like, first thing we have discussed about the matters, right? We have discussed about the matters. Then we have discussed about the mixtures. So in case of the mixtures, we have discussed about homogeneous mixture and heterogeneous mixture. Right? So what do you mean by mixtures? Where more than one elements are or molecules are combined together. Right? Then we have discussed about pure form of the matters. So that's where we have discussed about compounds and elements. And along with that, even we came to know the difference between molecules and compounds. So these are the some of the points just now we have discussed. Any doubts in this? If you don't have any doubts, we'll move to the next one. So now, when it comes to the next one, okay? So as I told, in compounds, they cannot be separated by the physical methods. They have to be separated by the chemical methods only, where we have to break the bond. So that means, whatever matters we have, it can have two different properties. One is physical property and another one is chemical property. So that's where we have the two types of property for a matter, physical property and chemical properties. Physical property means, if I am right, it is nothing but bhautika lakshanagalu in Kannada, if I want to tell. So that's where we have the physical property. And chemical property means rasayanika lakshanagalu, right? So that's where we have the physical properties and chemical properties. Now when I am talking about physical properties, if I am not using any of the reagents, any of the reactions, then I am talking about the physical property, just like boiling point, melting point, or color. So these are some of the physical property or appearance. All these things you are going to study in your practical salt analysis, right? So that's where we have the physical properties. But when it comes to chemical properties, it is with related to reactions. Reactions with some of the reagents. That's where we have the chemical properties. All of you have understood? So that's where we have chemical method, physical method. Physical method means depending on the difference in the boiling point, melting point or color, they will be separated from each other. That's why they are called as physical methods. Distillation, difference in the boiling point, we are going to separate. That's where technique is called as distillation technique, right? So that's why they are called as physical methods. That's what we have discussed with respect to the mixtures. They can be separated by using the physical methods, right? But when it comes to chemical, where they cannot be separated by physical method, I told chemical method, that means based on the reactions or where we have to break the bond, because during the reaction there will be breaking of the bond and there will be rearrangement of the element will takes place. That's why they are called as chemical reactions. Anyway, which we are going to discuss in detail tomorrow. Okay? So today's class is not over. That concept we are going to discuss in next class. But anyway, we will continue. So when it comes to a matter, as I told, it should have its own mass. I use the word mass. Right? So what do you mean by mass? All of us we know the SI unit for mass is kg, or it can be expressed in grams, whatever it is. That conversion is important, right? So that conversion is important. Say for example, I have 1000 milligram, which will be equal to 1 gram, right? So same way, if I take 1000 gram, which will be equal to 1 kg, that's where 1 k, k stands for 1000, right? So that's where we have the conversion factors. All these things you should remember. Now if I observe it carefully, mass is nothing but particular element present in a particular volume. That's where we have the mass. Volume in the sense in that particular I can tell area or whatever it is. That's why it is called as mass. Say for example, I will have 10 marbles. What is the mass of combined those 10 marbles? Or each marble will be made up of different amount of atoms. So all those atoms combine together to form a marble. So that's where it is called as mass. Now if I take that particular marble, whether I will take it in Mysore, I will go to Shimla, or I will go to USA, or I will go to Mount Everest, whatever it is, mass cannot be changed. For example, Raghavendra sir is there. This Raghavendra sir is made up of so many number of carbon, hydrogen, oxygen, or whatever it is. Different atoms are combined together to form different tissues, and all those tissues are arranged to form the Raghavendra sir, right? So if Raghavendra sir is in Mysore, mass will be one type, one mass will be there. If I am moving to some other place, my mass will remain same, it cannot be changed. Mass is constant, that's where we have the mass. But we are going to use another word which is called as weight. We are going to use another word called as weight, because in the next this one we are going to talk about atomic mass and atomic weight. Atomic mass and atomic weight. Students will get confused. What is this? Atomic mass or atomic weight? Which is correct? For convenient purpose, they will use both, but there is a difference. One is talking about mass, another one is talking about the weight. Weight, SI unit will be Newton. SI unit will be Newton. Right? So why? What is that difference? Here I told SI unit is grams or kg depending on the amount you are going to express, in which format you want to express. But here I am talking about the Newton. That is because weight is related to the force. Weight is related to the force. Right? Say if Raghavendra sir is standing here and touching to the ground because of the gravitational force. I am touching to the ground due to the gravitational force. There is some force acting on us. Right? So that force is related to the weight. Therefore, it will be expressed in the terms of Newton. Now, all of us we know that gravitational force will be slightly variable at the levels, different levels. If I am at sea level, I will be having highest gravitational force. If I go up 1000, 2000 meters up, then slowly gravitational force is going to decrease. That means weight is variable. Weight is variable. If I have something which will have some weight at Mysore, if I go to Mangalore, there will be slight variation. If I go to Shimla, much more variation. That means, that is because Mangalore is at sea level, then comes the Mysore, then comes the Shimla. So therefore they are at different heights from the sea level. So therefore weight is variable, mass is constant. But whenever you are using the word, we will use together to avoid the confusion, that's all. But actual meaning is different. Okay? So that's why we have the mass and atomic weight. Please remember about these conversions, because to solve some of the problems you should know these conversions. Okay? You should be knowing this conversion. Next comes the density. Next comes the density, because as a chemistry student, always will talk about the density. Density of this particular liquid, density of this particular solid, because whenever we are talking about the matters, matters can be of three different forms majorly: liquid, solid and gas. Right? That's where we have the matters. If I talk about water as a common example, water can be present in a liquid form, which you are going to drink. It will be happening at room temperature. If I want to talk about the water as a solid, that is nothing but ice. So when it will happen? Either at 0 degree Celsius or below 0 degree Celsius. That's where ice will be there. Water will be present in the form of solid. If I go to the gas, I can take vapors, water vapors. Right? I can take the water vapors. Where if I go above 100 degrees Celsius, then water will be converted into gaseous form. Water will be converted into gaseous form. Or in the moisture, whatever atmosphere is there, it will have some amount of water vapors. That will be interconversion, always it will be happening. Liquid to vapor form. So if I am talking about gaseous water, then above 100 degrees Celsius, if I am going to heat, then I am going to get the gaseous molecules of water. So that's where we will have the different states of water molecule. Same way, all the matters on this earth, they can have the three different format: liquid, solid and gas. Fine? If I take iron rod, yes, they can attain the different state levels or different states. Only thing here is different temperature, because each matter they have different conditions. Only those conditions they will be in different formats. Fine? So due to that, when I am talking about chemistry, since it deals with the study of the matters, since it deals with the study of the matters, therefore, whenever I am talking about the density, if I am talking about a solid or liquid, whatever it is, we will be talking about the density. Now, all of us we know that density is equal to mass by volume. Density is equal to mass by volume. All of you will agree? You people have studied this one. Now, what should be the SI unit? Here it will be kg. Mass can be expressed in kg. Now, what about volume? What about volume? Yes, Rishabh, it is mass by volume. What about volume? Volume is related to three factors. Volume can be expressed when you are going with three factors. So therefore, generally we will write A cube. When I am talking about area, I will write it as A square. Right? So that's where I am having volume. And here I am talking about area. So when I am talking about volume, three factors are required. And when I am talking about area, two factors are enough. So that's where I have the volume and area. Now, normally volume will be expressed in terms of meters. Volume will be expressed in terms of meters. So therefore, meter cube. Say for example, I have a cube. I have a cube. Now when I am talking about this particular cube, I want to go with volume of this cube. What is that volume of this particular cube? That will be the question. So in that case, I will go with the A, and another A will be here. So that's where I will take the three factors. Right? So width, length and height. Since it is a cube, everything will be same, equal. So therefore, I will simply mention it as A cube. So which is that one? Width, length and height. Right? So that's where I have the volume. Since I am talking about the length, I can use the meter as the SI unit. I can use the meter as the SI unit. Even I can reduce the length by using the unit also, where I can use centimeter depending on my requirement. Depending on my requirement, I can change the values. Okay, so that's where I have the kg by meter cube as the SI unit for the density. Fine. So that's where we can tell that ice is having lesser density. Ice is having lesser density than water. Right? In a summer season, students will go to their home. They will tell to mother, give me a lemon juice, cold lemon juice. So in that case, when lemon juice will come to you, ice cubes will be floating on the surface. So that shows that ice is having lesser density than water. So how it's possible? How it's possible? Because ice, it is a solid water and water is a liquid water. So both are made up of water. How come their density will change? That's what I told. Element or a molecule can be in more than one state. Either it can be liquid, it can be solid, or it can be gaseous state. So in different conditions, they will have the different density. In this case, liquid water is more denser than that of the ice. Liquid water is more denser than that of the ice. See for example, I have a ice cubes in a container, in a glass. I have a ice cubes. So this is the volume which is occupied by these many water molecules which are present in the solid form. Now when they will get melted, now same amount of water, it will occupy the lesser volume. it will occupy the lesser volume. Can you observe here? I have not removed any ice cube. Same ice cubes, it has been converted into liquid form. No water molecule has been removed outside. But what is happening? Volume is getting decreased. So volume is getting decreased. That's where volume is in the denominator. So density and volume, they are inversely proportional to each other. Mass and density, they are directly proportional to each other, right? So therefore, since water molecules will be occupying higher volume, so therefore density will be less. Since water molecules will occupy the less volume, so therefore density will going to increase. Because volume and density, they are inversely proportional to each other. All of you have understood? Any doubts? Any doubts? Now that's where I have the 100 centimeter is equal to 1 meter. 100 centimeter is equal to 1 meter. All of you have understood? Fine. So now I will come to the last part for today's class. That is, when it comes to liquid, we can use the volume in another way. We can use the unit for the volume in another way, which is not actually an SI unit, that can be liter. Okay, that can be in liter. Now when I am talking about this particular unit, which is not a SI unit. Now when I am talking about 1 ml, that means 1 milliliter. 1 milliliter. Okay, so that's where we have the 1 ml. Same I can express 1 liter as capital L, 1 liter. 1 milliliter, 1 liter. Fine. So that's where I have got the different units for this particular liquid, where volume can be expressed in different units. Normally, 1 liter is equal to 10 meter cube. 1 liter is equal to 10 meter cube. Then 1 liter should be equal to how many centimeter cube? If I want to express same thing in terms of centimeter, how it can be expressed? So therefore 1 liter will be equal to 1000 centimeter cube. 1000 centimeter cube. That is because all of us will know 100 centimeter is equal to 1 meter. 100 centimeter is equal to 1 meter. Please remember this one. So 1 liter is equal to 10 meter cube. Therefore we can write it as 1 liter is equal to 1 decimeter cube. That means 10 meter cube. 1 decimeter cube. That is dm cube. That is 10 meter cube. So the same way 1 liter should be equal to 1000 centimeter cube. That is because. Okay. Fine. All of you have understood? Any doubts in this? Anyway, we are going to continue in the next class, but any doubts in this? All these conversions you should know, because for your exams, so while solving some of the problems, you have to utilize these conversions. Fine? Any doubts? Okay. So if you don't have any doubts, I will stop here. So in tomorrow's class we are going to continue, where we are going to discuss some of the important concepts related to your board exam. Okay. Here these concepts may not be asked directly, but it will be utilized in solving some of the problems, no doubt. But whatever tomorrow I am going to discuss, you can expect the question directly on those concepts. Fine? Okay, then take care. Bye. Okay. Thank you.